Now, we have another car that has a little bit less of a mainstream root cause. This is a mill-on, runs rough. It's a 2004 Ford Explorer. And we go in and check our DTCs. And we have PO 172, which is, again, rich. We have fuel system, which is in closed loop. And we have short-term fuel trim at about 10 minus. Long-term is minus 25. And we have long-term minus 25 on both banks. The engine was at about 1,700 RPM, and the vehicle was just barely moving when it set this DTC. The mass airflow at that moment was about 27 grams per second and 22% throttle position. What I want to draw your attention to here is the oxygen sensors are all, at this moment, again, are all basically demonstrating a somewhat rich mixture, but they're not pegged. And so the PCM is able to create fuel control here. This is the PID that Ryan was talking about, vehicle power. In this case, the PCM is reporting a fully charged electrical system. The rest of the freeze frame is not really the only thing that we can look at is our fuel level. Input was pretty low at this point, but our most of the other PIDs are looking pretty well in line. So let's take a look at scan data. Now this is using an IDS or a Ford factory scan tool, and this allows us to see what's going on over time. So time is going this way. So all of our PIDs are displayed where we can see a trend over a long period of time. Also notice the technician put up the Barrow PID at 156.5 hertz and 99 kilopascals. That Barrow PID is an important one to look at on Fords if you're wondering if there's something wrong with the mass airflow sensor. But the real key takeaway on this slide is that we've got long-term fuel trim at minus 25 on both banks, and this is a problem that is pretty consistent, and it's just steadily running rich according to the PCM. Also, if we take a look at our scan data and bring the O2 sensors in, the upstream O2 sensors are in fact switching. They're being able to switch, so the fuel control has in fact corrected the problem to the degree that we can get the upstream O2s to switch. So it is it's a fuel control problem that PCM has actually been able to bring a lot of the way back to center. Well, many of you would not think to look at the PIDs that we're displaying here. But I got to tell you, those of you that were in my E85 class, we talked about this back then, and that is the E85 system has a virtual flex fuel sensor on it. And if that thing goes haywire, we can have some serious problems. If you take a look up here in the upper left-hand corner, our fuel factor is learned, says yes, and our inferred ethanol percentage is almost 79%. After talking to the driver of the car, the technician found out the guy has never put E85 in his truck. So we have a problem here. When we look for TSBs on this particular vehicle, we find out there is a TSB that points to this PO 172, 174 exactly, and it says that there needs to be a recal on the PCM that is going to help it not mislearn the ethanol content in the tank, because this is all done through fuel trim and is all done virtually by the PCM. The way it is supposed to work is you refill the vehicle, and the PCM looks at the change in fuel trim right after the refill and then says, oh, okay, we know we added X amount of ethanol, so we're going to change the ethanol content. Now, when ethanol takes more ethanol to run the engine than it does gasoline. So if the PCM thinks it's got almost full E85 in the tank, it is going to increase the base pulse width, and that will make the base pulse width wrong. The oxygen sensors are going to pick that up. They're going to go rich, and they're going to start causing fuel trim change, eventually turning on the light and setting this DTC. So this is the bad side of E85 here. So we check for flash. And this is what the process of reprogramming the PCM looks like. And when it's all said and done, the technician fires up the truck and notices that our long-term fuel trim, of course, has reset to 0, but our short-term is about 10%. And it's really not going, it's not ramping either direction, is it? It's pretty much hanging right in there at 10%. Now, of course, if you really wanted to get the full picture on this truck, you would need to drive it until you could get your fuel factor learned PID to switch to yes. But the evidence that this technician has at this point is pretty overwhelming that he's fixed his truck. So he's probably going to let the customer go drive it and maybe check back with him in a couple of weeks to see if that fuel factor, the inferred fuel factor, is still down there in the single digits, indicating that PCM is now on track with the learning the fuel.